Hello everyone, welcome to Mentor Buddy, and this is your mentor Akhil. Today we are going to discuss the question which is based on probability. Now, directly coming down to the question first. Okay, the question says find the probability that a leap year chosen at random will have 53 Sundays. So we can see that as far as this question is concerned, it imbibes the logic of both, that is calendar and probability. So in order to solve this question, we need to know the basic logic of both calendar and probability. So now let's get to the basic logic of calendar and probability first. Now, according to the basic rule of probability, so probability of any event is basically the ratio of number of favorable outcomes upon total outcomes. For example, if a coin is tossed, so what is going to be the probability of getting the head? So we know out of head and tail there's going to be one outcome and the total outcome is going to be 2. So in that, the probability of getting head or tail is going to be half. Another practical example which we can connect in this case, that is in a particular day whether it is going to be rain or it is not going to be raining. It will rain or it is not going to be a raining day. So it will be raining or it will be not raining. Again it is going to be 1/2. Or let's say I'm going to consider another case. Let's say there are two die. This is first die, this is another die. Die is basically a cube figure which comprises of 6 phases, and the numbers like 1, 2, 3, 4, 5 and 6 are going to be numbered on each phase. So let's say the question is, if the two fair dice are rolled simultaneously, then find the probability of getting the sum as 11. So we know the sum 11 can be approached in two ways. Either it is going to be 5 and 6 or it is going to be 6 and 5. So these are going to be the two favorable cases. So in that case, that will be 2 will be the favorable case, and the total number of cases will be 6 cases from this one and 6 cases from this one. 6 into 6 will be equals to 36. So that will be equals to 1/18. So the probability of getting the sum to be as 11 will be equals to 1/18. So that is about the basic probability. And the another thing which we need to be used in this question, this very question, that is the logic of calendar. So we know a normal year comprises of another 365 days and one leap year comprises of another 366 days. Now coming directly to the question, in order to imbibe these two both logics in our coming question, and the question says we have to figure out the probability that the leap year chosen at the random will have 53 Sundays. Okay, these are certain notations which we had made which are going to be very helpful in the question. Now first let's understand the question. The discussion is about a leap year, right? So we know that as far as one leap year comprises of another 366 days. Now let's first figure out what are going to be the extra number of days in a particular leap year. So what I'm going to do, I'll divide these 366 by the number 7. So I know 752 times will become 364 and the remainder will be 2. So this shows that in a leap year, that is in a span of another 366 days, there will be 52 perfect weeks and there will be remaining 2 extra days. So these 2 extra days are going to be the key to fetch the right answer for this very question. Now let's understand one simple another thing, that is the year is going to be continued. So these 2 extra days are definitely going to be the consecutive day. They can't be at a gap of 2 or 3 or so on. They are definitely going to be the 2 consecutive days. So in that case, the set of 2 consecutive days which can be formed are like Sunday Monday, Monday Tuesday, Tuesday Wednesday, Wednesday Thursday, Thursday Friday, Friday Saturday, and Saturday Sunday. So these are going to be the formation of total 7 cases. Now the question says we require 53 Sundays. So as we can see, in these first fair 52 weeks, definitely there are going to be 52 Sundays, right? So there are already 52 Sundays, and these remaining extra 2 days require one another Sunday in order to make the total number of Sundays to be as 53. So in that case, I can see the Monday Tuesday case is not going to satisfy the condition. Tuesday Wednesday again not satisfying, Wednesday Thursday not satisfying, Thursday Friday not satisfying, Friday Saturday again not satisfying. So only 2 options which are going to satisfy the need of the condition, that will be Sunday Monday or Saturday Sunday. So we can see these are the 2 favorable cases which are satisfying the need of the condition. So 2 are going to be the favorable cases, and the total number of cases are going to be 7. So in that case, the correct answer is going to be option number A, that will be equals to 2 by 7. The most important thing which we need to understand in these kind of questions, that they are the blend of 2 different topics. As far as this question is concerned, it comprises the logic of calendar and the logic of probability both. So in order to get the right answer, we need to know the concept, the basic concept of both of these questions. And another important fact about this very question is, that is, the extra 2 days which we are getting, which are going to get me the answer, are going to be the definitely the consecutive days. So the consecutive options are going to be only 2 options, that will be this Sunday Monday or this Saturday and Sunday, which requires and gives the correct answer to be as like 2 by 7.